Okay, how bad is matrix addition? Not bad. How about subtraction? Not bad, as long as the matrices are of the same order. Good. If they're not the same order, what would we do if they ask us to do matrix addition or subtraction? Yeah, no solution. It's impossible, right? Okay. What if they want us to do what we would call scalar multiplication? How hard is that? A little harder. What am I talking about if I say scalar multiplication? What's going on? What is scalar multiplication? Look up in your notes. It's not this page. It's an earlier page. It could be a fraction, or it could just be something as easy as, yeah, remember him from yesterday? How bad was that? Okay, that wasn't bad. Now, they might ask us to factor out something in common. That's possible, but just the idea of scalar multiplication is kind of like distribution, right? Okay. So then we talked about some properties just for a second, but the one thing that we didn't see anywhere on this page, all of these made sense. You didn't have to write them down. You don't have to memorize them. The one thing we didn't see was, what about this A times B or B times A? We haven't seen any properties like that because we didn't know how to do matrix multiplication. Yesterday, what did I have you using to try to follow along with the process? Both fingers, okay? One finger goes to the first element on the left matrix, right? One finger goes to the first element in the right matrix. However, they're going to move differently. Kiddos, when we talk about the order of something, I'm going to zoom in on the example down below. When we talk about the order of something, there are two numbers with a little x in between, which we would say is by. Not multiplication, although this is. Oh, no, this is order. It's also multiplication. Okay, let's go down. Hold on. Here we go. Okay, right there. 3 by 2, right? What does the first number denote? How many rows? Rows are horizontal. Columns are up and down, right? Like the Greek columns would be like actual columns that are supporting like a building or a structure. Okay, so the first number denotes how many rows, right? The second number denotes how many columns. So the order, don't we always go rows, then columns? Do you agree? Okay, whenever we do order, it's rows and then columns. Whenever we do order, it's rows and then columns. Yesterday we saw, just for a second, actually it's like for a minute or two, that the only time we can do matrix multiplication is when the number of columns equal the number of rows, when the inside numbers match. If they match, it's legal, let's go. And if it's legal, let's go, the answer is going to have the same size as the outer two numbers. And not just the same size, but it's going to have 3 rows and 2 columns. That's going to be the size of the answer. But this will also help us with our finger method of matrix multiplication. Because on the left, what are we going to go by first? Rows. We're going to go the first row with the left-hand matrix. We're going to go by rows on this matrix. And guess what we're going to go by on the other matrix? Columns. So we're going to go by rows and columns. So they are both in the first entry spot, but this is the first entry of the first row. This is the first entry of the first column. Up at the top of the page, didn't I have you guys write down yesterday, cross down? I want you to remember for matrix multiplication, you have to go across first and down second. But we're doing them at the exact same time. So my left finger is going to be going across as my right finger goes down. Whether you're in the first row, first column, the second row, first column, or the third row, first column, this one's always going up or down, and this one's always going across. I can also skip over to the second column, first row. And as I do my cross down procedure, we're going to go ahead and be able to match up to do matrix multiplication. So who can figure out, and we did it quickly yesterday, where the positive 3 and the negative 12 came from? Was I stealing pieces out of the matrix? Can you guys look right now? Do you see a negative 12 up there anywhere? No. So I must not have been stealing entries. I was instead doing multiplications. Okay, multiplications. What two numbers would multiply to be a positive 3? If this helps, you can actually think about if I'm getting a 3 by 2, I'm going to need A11 and A12. I'm going to need A21 and A22. I'm going to need A31 and A32. What do you see, Leo? Yeah. Good. -1 times -3. Starting in the first row, first column. So I'm going the first row, -1 times -3, plus 3 times -4. In order to get A11, I need to go the first row with the first column, multiplying the corresponding entries and adding them together. So +3, -12. Okay, get your fingers on there and follow me. We're going to try and do some muscle memory. Hopefully it'll kind of help. All right? So for the very first entry, you guys have your fingers on the first ones? Okay, multiply. What's -1 times -3? Then add. What's 3 times -4? Cool. Add the two together and we have A11 by doing the first row with the first column. How am I going to get A12? I need to do the first row with the second column. So first row with the, what we think of is cross over. Okay, for my next entry, we've got to go over. Now let's do it again. So what's -1 times 2? Are you following me? Cool. And then move over and down, right? What's 3 times 1? You guys see how I got -2 plus 3? Okay, fill in whatever you don't have yet, because we're going to keep going to finish this matrix. If you notice, we have 1, 2, 3, 4 more to do. 1, 2, 3, 4 more to do. But I really think going across with the left hand and going down with the right hand, multiplying the numbers that you see, and then as you shift, putting an addition sign and multiplying again, will help you guys keep track. So if you guys notice, now I'm going to what row? So I must be going, which one does rows? This one. Go to the second row. And then I need to have the first column, right, for this entry? Okay, so second row, first column. Here we go. What do you see? No. Multiplication, right? We only add when we shift. So if you multiply -12, good. Fill it in. -12, and then I'm shifting. So what are you going to do after -12? Careful, when I shift, what operation are we doing? Addition, good. So -12 plus, now what do you see? +8, right? -2 times -4. Okay, so you should have written down -12 plus 8. I want you guys to see if you can do the second row, second column. Ready, set, go. Do the second row, use your row finger, with the second column, use your column finger. Did you guys get 8 plus -2? Yeah. Yeah? Okay, any questions? Someone not get 8 plus -2? You can watch my fingers if you want. We need the second row, second column entry. So second row, second column. There's 8 plus -2. If that makes sense, finish it off. Third row, first column. Then finish it off. Third row, second column. Third row, first column, third row, second column. Couple more seconds. Some are trying to actually follow. Do it step by step. Third row, first column, if you want to look at my fingers. What do you see? What operation should you put as I'm shifting? What do you see? Okay, we're multiplying, right? So -15 plus 0. And then we're in the third row. Which column? Second column. What do you see? 10 plus 0. So your final answer should have been -12 plus 8 is -4. 8 minus 2 is 6. -15 plus 0. And 10 plus 0. Who got there before me? Okay. Who kind of got there but made a mistake or two? Okay. I have a few that are kind of like I haven't owned it for myself yet. That's all right. That's all right. But this is our 3 by 2. Okay. I want you guys in your groups. Well, let's have you try it. Do I have an example already ready? Yeah, I do. Let's do this one. Let me take out this page real quick because I didn't need to make my own example. And sometimes my own examples get kind of nasty and messy with the numbers. I want you guys to write down these two matrices. Write them down. The goal is to multiply. Write down the two matrices. The goal is to multiply. Cross down. Left hand going rows, right hand going columns. Whatever you're pointing to needs to get multiplied. As you shift, you add. But before we can even start multiplying, you have to ask yourself the question, is it legal? How did we know if it was legal or not? We wrote down the orders. How did we know if it's legal or not? We wrote down the orders. Those of you that think you know the process, go ahead and try filling in. If it's legal. Those of you that aren't quite sure whether or not it's legal. Ooh, it's not a 3 by 2, it's a 3 by what? What's the order of the other one? Yeah, 3 by 2. Some people are already going, and the reason they're going is because it's legal. And why is it legal? The insides match. If they didn't, we'd say forget it, no solution done. But the insides match. What size is it going to be? 3 by? Good. So my answer is going to be a 3 by 2. It's going to look like, if it helps you guys to see, first row, first column, first row, second column. Second row, first column, second row, second column. Third row, first column, third row, second column. Sometimes I go too fast, so ready, set, go. Feel free to talk it out in your groups a little bit. If someone already thinks they have an answer, throw both matrices into your calculator. Actually do A times B in the home screen, literally with the little times symbol. See if you're right, and if you are, cool, be an expert for your group. And watch those that are lagging behind a little bit and say, hey, can I help? Mm-hmm.
A has always been 2 columns. So I was just thinking, since it's multiplication, you can just do BA and just have it, I guess, since that's the way we've been doing it. Because you can't go across. Once you go across with the from 0 to -1, you can't go across from 2 afterward.
What are you saying?
I think you're saying, like, when to know whether or not it's legal? Is that what you mean?
No, because, I mean, since you already asked me.
Well, no, but they went ahead and got it, and they solved it. You guys got the answer, right? Oh. Okay, sorry. I thought I asked you that, and I thought you said yes. Okay. So what we're saying is, and a couple groups already asked me that. This is a new problem, right? But the problem is, you guys are saying it's impossible, but the math shows it possible. So we just have to learn how do we do it when there are 3 columns and 3 rows. So Chris, what did you figure out? Even though it's a different problem than the last one, how did you apply the strategy to be able to solve it?
Use the cross and down.
Uh-huh.
Multiplied the 0 by 2, the -1 by 4, and the 2 by 1. And then for the second column, I multiplied 0 by -1, -1 by -5, and 2 by 6.
Good. I'll have you pause there because you have the system down. They might not yet. What was different? Well, as you went across and as you went down, everything matched up, which is why it's legal. But instead of just having 2 things to add, what do you have now? 3. What if it was by 4 and 4 by? What if there were 4s in the middle? You would then have 4 things to add, because you would have to go over 4 and go down 4. So it was a great catch that you guys were like, hey, it's different, and that's exactly right. But the process is still the same. And the process then leads us to the correct answer of when you point, multiply, and as you shift, add, right? And multiply. And then as you shift, add, and multiply. The nice thing is the process is the same. It's just going to be a little bit longer. So then as we go to the first row, second column, I'm still doing the first row with my row finger. I'm now moving to the second column with my column finger. And as you guys saw, Chris was like, hey, and I got 0 by multiplying, 5 by multiplying, and 12 by multiplying. Now, for those of you that are just like, oh, keep going. I don't want to give the answer right away. But for those of you that are like, hey, I already got there, cool. There's a second part to this problem. Now try to do B and then A. Now, if you do B and then A, you better rewrite it with first and A second, because now what's going across and what's going down has switched. So instead of switching your fingers, which will just get super confusing, instead just write the matrices, write B first, then write A, and try to do your cross down. So if you've gotten the first one, which you could have checked by putting this in your calculator A, this in your calculator B, and then actually doing the times like I showed you on the screen, there is an answer. It does work. If you think you've gotten that, then try to do the second, but just listen to my advice. Write B first, then write A. Meanwhile, I'm going to finish up the math for this one. 1203. Negative 6, 0, 18. 14, negative 4, 8. Negative 7, 5, 48. Did anybody get the same one as me? Okay. Questions? Questions. Joel. Okay. Well, you see third row, first column, right? So I'm going here, and I'm going here. So then I just match it. So 14, because remember we're pointing to multiply. 14 plus negative 4 plus, yeah. We're actually going to use the first column 3 times. We're going to use it for this and, yeah. So it's okay. Josh. Other questions on how I got the numbers? How many of you guys are actually literally like using fingers and following? Okay. How many of you are kind of mentally able to do it without really using fingers? Okay. Okay. That's okay. Some people, it's good to have that actual like motion going on, or to be able for their brain to kind of keep track. But some of you, it's too much. Like it actually distracts your brain. So that's okay. Just be careful. How many of you guys are kind of jumping here because you're doing that mental math? Is anybody jumping to the end? Okay. I would too. But for some of you, it's safer just to write it out and then just add it all at the end. So just be careful with the mental math. You guys know mistakes can happen. Okay? Now, you guys are trying to do B times A, right? I'm going to make a new slide real quick, because if I start going down, we're not going to see it as well. Can someone help me out really quick and read what B, because B times A, I warned you guys, it's easier just to rewrite it. What's the B's matrix again? One, 6? Oh, Lo siento. Okay. But I also need A. He was a 3 by 3. Okay, go ahead. 3. Okay, that was a 3, right? Okay. Whew. If you guys had the method, you might have just started solving. Don't say anything. You might have just started solving. And to solve, some of you kind of got the method. You're like, okay, cross down. Here we go. 0, -6. If you look back at matrix multiplication, you have to be able to have corresponding entries in the rows and columns. What would have happened if you had written this out to check? No bueno, no solution. No es posible. It's not possible. There you go. But do you guys see how even if you know the method, you just started going? Because that's what we do in math, right? It's like, okay, fine, multiply, let's go. Would it have worked? And that's the point. It doesn't work. No solution done. Are we tracking? So what does this finger do? What does this first matrix do in the matrix multiplication? I'm always going across, right? Okay. What does the second matrix always do? What am I always doing? Down. When I correspond the entries, whether you're pointing or whether you're just looking, when I correspond, what operation am I doing? Multiplication. And as I shift, what do I need to be thinking? Addition. And I have to complete a row and a column, hence why that one doesn't work. But I have to complete a row, complete a column to get an entry. Are we kind of tracking? Okay, let's do one more then, just to make sure we have it solid. Because with you guys, let's not do that one yet. I know that repetition is kind of key. Because if you just kind of like, I understand it, tonight you'll be like, what was it again? Okay, one more time. Ready? What if I was to do something like, let's just do find AB again. Okay? Matrix A is equal to 1, -1, 2, -2, 0, 3, 1, 1. Uh-oh. What size is this? Okay. Do you guys want to think like a teacher for a second? If I'm making this up off the top of my head, which I literally am, what size am I going to have to make B? 4 by. Okay, 4 by something. Good. So let's do 0, 1, 5, -3, 2, 1, 7, 0. Okay. Go. In some ways it's big and in some ways it's small. It's okay. But guys, is it legal? Yes. How many are you adding together each time? 4. Good. Let me give you a little bit of time to work. If you want, you can always double check it in your calculator. I've finished it, but it's somewhat hidden unless you're looking at my screen over here. I'm going to show the steps to double check my work because I did do a lot of mental math. I double checked by writing my steps, and I think negative 15, positive 6, 24, negative 8. I think I was right. How'd you guys do? Is that all right? Anybody need help finding their mistake, or are we okay? Mistakes can definitely happen. Okay. We kind of get a feel for it, yeah? The final solution was supposed to be a, and it was. The final solution was supposed to be a 2 by 2, and it was. I bet you made a positive negative mistake. You were saying 13. Because negative 5 plus 4 is negative 1, plus negative 14 is negative 15. Your mental math, yeah. Yeah. So easy to do, right? Careful. The mental math makes it go faster, but it's so easy. Now, here's a question. What? How are we supposed to do a squared? Oh, it's easy. 9 and 4 and 1. You just killed a puppy, except I didn't even write the matrix mistake up there. You can't just quickly square complicated expressions like matrices or binomials. I know you guys were like, 9, 4, 1, yay, this is good. Except a squared, isn't it the same as a times a? So wouldn't we need to write a again? And then, wouldn't we need to go cross down? Yeah, I'm a little curious too, but anyway, cross down. This finger, the left one, always goes as the right one always goes.
Impossible. It's no solution.
No solution. Can we ever square a matrix? Yes, not this one. Can anybody think what size a matrix would have to be for us to be able to square it? A 2 by 2, or a 3 by 3, or a 4 by 4. Can it ever be non-square? Remember, square matrices have the same number of rows and columns? Can it ever be non-square to square it? No. Does that make sense? Okay. So, careful going quickly, because I promise you, if this is a question on a test, will I have 941 just waiting for you? Mm-hmm. So, you got to know how to do it, yeah? Kiddos, once again, I don't need you to memorize these properties. So you could write them down or you could just leave it off. What I need you to see, and hopefully you have seen, the big idea of what is here, actually what I need you to get is what is not here. What is one of the most basic multiplication properties that is not on this screen and cannot ever be said for matrices in general? What property is missing? Look at the names. Distributive, associative. I mean, there's this transitive one, but that's different. That's like A, B, B, C, A, C. Starts with a C and ends with a mutative.
Commutative.
What is that property? Commutative property of addition is A plus B equals B plus A. What's the commutative property of multiplication? Why can't I say that for matrices? Multiplying this direction differently than multiplying that direction. I can't necessarily say that just because this is an answer that will be the same. And as we've seen, just because this is possible doesn't mean that's possible, right? I'm not saying that'll never be true. Square matrices, maybe, because whichever way you do them, they'll be legal. But even with square matrices, just a hint, even if square matrices get switched and multiplied, even though they're both legal, you're going to get very different answers except for one very specific time that we'll see next section. Ooh, Now, I'm not going to go through and make you guys do this math. Well, you guys start writing. Let me show you what happens. I'm going to do the multiplication fast if that's okay. I'm going to do the multiplication fast if that's okay. I actually forgot that I introduced this to you, this section, so it's kind of piggybacking off what I just said a second ago about how A times B cannot always equal B times A. And even more specifically, A times B will not usually equal B times A. But let me show you something interesting with this guy as you guys are writing down the example. There's a lot of zeros going on, yeah? What if we go this way? Huh. Whichever way you cut it, whichever way you multiply, it's going to end up being the exact same thing. Hey, it's the identity. And didn't we say yesterday that this multiplicative guy was missing? And then I was like, isn't there a matrix called the identity? Maybe he's the multiplicative one? Some didn't. Maybe some of you did. I did kind of foreshadow like 3 days in a row. But anyway. And the cool thing about the identity is he's not just an identity in that you multiply him a certain way and he ends up equaling. But actually, if you multiply him the other way, it also works. He's one out of two special matrices that whenever you multiply, whether it's as the second or as the first, the result will always be the same. There are two types of matrices. One's an identity, and the second, well, we're going to have to learn a little bit more to get there. All right. Do you guys see how kind of it works, like why it's the identity? There's so many zeros that everything cancels except for the one term that you actually need to finish them off. Okay. Kiddos, this section, I don't necessarily know if I need you to totally write all of this down, but there is a term in here that I kind of need you to see. I've mentioned it, I think, a couple times, an augmented matrix. I think I might have even said doubly augmented. It's a little early for me to talk about that. The long story short is I just need you to get down. There is a way of writing a system using matrices and variables. For our REF, we just took all the variables out. We ignored them completely, and we said, forget it, put a dotted line, we're done. It's because we hadn't learned matrix multiplication yet. Technically, what's going on when we make a matrix and we totally ignore the x's, y's, z's, or the a's and the b's and the c's, I shouldn't say that, the x's, y's, and z's, or in this example, the x1s, x2s, x3s. What's technically going on is that we're factoring out all the coefficients from all the variables. And it's probably a bit hard for most of you to see. But technically, we can, not that we normally do or even normally will, but we can look at this as a multiplication problem and say, oh, we're going to go ahead and pull out the x1, x2, x3 and put it back in the column where it belongs. we're going to pull out the x1, x2s, x3s from everyone and put it in the column where it belongs. Cross down, cross down, cross down. Technically, when we would write a system of equations as a matrix with a dot, 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 and the variables missing, we were factoring out the coefficients and separating them from the variables. You don't really have to dig too deep into this concept, this section. It's more of just an understanding how we can rewrite a system as an equation, not just as a matrix with a dot, 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 but as an equation. Long story short, we could write all the coefficients in a matrix. We could write a column matrix of the variables. And then we would have another column matrix of the constants. And the coefficients will always be a square matrix, or it should always be a square matrix. If it's non-square, remember it's one of those weird examples where maybe we're missing a row, so we're going to have to let z equal a, or we're missing a column, so maybe it's going to be impossible, so we'll have to be careful. This isn't an idea that you're going to have to dig in too deeply this section, but now that we've learned matrix multiplication, maybe we can see how we can pull the variables out and have the coefficients be totally separate. But once again, the big thing on here is augmented matrix means taking a system and saying coefficients, variables, constants. That's about it. That's about all I need you to see. I'm going to go ahead and dual screen it, kiddos, just so that those of you that are getting everything down on that page, you can go ahead and see it. But we're going to look at the last example. Ooh. The last example. It's a word problem, but it gives us some stuff, and I'm going to totally help you think through it. Because they don't label the matrices, and yet the rows and the columns have meaning. They don't label the matrices, and yet the rows and the columns have meaning. If you guys notice, we'll see this just for a second. A times B. We're trying to find A times B. And we have a 3 by 3 being multiplied by a 3 by 2. These two need to match. Those two need to match, which they do. Which means ultimately there's really just 3 labels going on. 3 different quantities going on. Now this is definitely a multiplication I'd let you use your calculator for because of all the nasty decimals and all that jazz. But here's the dealio. If someone could in their calculator, because we're getting kind of on time, throw these in and multiply them. If you were to read this problem, you would have to pick out and say, okay, there are 3 different things being measured. I see a group of 3 for the types of milk. I see a group of 2 for the money. I see selling prices and profits. That's going to be a 2. Oh, wait, there's only 1 2. Okay, so what must be the selling prices and the profits? It must be the number of columns right here. The profit. I only have 1 2 in this whole problem. The struggle is, what's my other measurement of 3? 3 types of milks. I have 2 different types of money measurements. Ready? How many days in a weekend? For businesses, the weekend is Friday, Saturday, Sunday. And you guys could probably tell why. Friday, Saturday, Sunday. So we have 2 different measurements of 3. The question is, I wonder which one's which. You would have done this in your calculator. The question is, which one makes sense to be the types of milk and the days of the weekend? You guys might see one of those in section 8.2. Try to think through what would make the most sense. Section 8.2, totally due on Monday, and I'll see you guys later. Good job today. Work on cross down over the weekend, okay?
Oh, can I come see you after school for that?
Yeah.